Hello guys, welcome to the channel. Today let's make this. So you see, this is a simple program in which random shapes with random colors and at random position are displaying over the screen on top of one another. So we are going to make this today. So we will be using C++ and a library called Sfml. So it stands for Simple Fast Multimedia Library. So we will make this small program using C++ and Sfml. So let's get started. So before that, we should know some basics of C++. So I'm assuming that you are already aware of them. So in the excitement, I forgot to introduce myself. So I'm also learning how I decided to learn in bit interactive way. So I learned few things and few concepts and I applied them and I made this simple program. So I'm just recording it to show how I made this so that you can do it as well. It will make learning more efficient and more interactive. So as we gradually move into the series, we will see more things. But for now, let's just get started. So I hope the screen is clearly visible to you. Okay. So as you see, I am in a program. I'm in a folder which I named M shapes, and in this folder, I only declared. Let me just delete this. So in this folder, there is only one file called main.cpp, and you are already aware of what main.cpp is. It's a source code file. So first, let me check if C++ compiler is working perfectly or not. For that, I will just print hello world over the screen. So hash include IO stream, which stand for input output stream, and using a namespace std created a main function for the entry point, and here using a output stream object cout and passing the string hello world with new line and returning 0, which means everything is working fine. So I would also like to tell you that I'm also learning, so it may possible that I will do some mistake. So if I do them, please correct me out and feel free to ask anything in the comment section related to this. And also, this is my first video. Here, to run the program, I'm using the operating system Linux. So to run this simple program, what we have to do is to tell our compiler to compile the file main.cpp. That is it. You see, it successfully compiled. Now, if I open this, you will see there is a executable or an output file created with the name of a.out. So let me just try to run this, which is slash a.out. So dot slash means we are in the current directory and we are referring to file a.out. So here it is printing hello world. It means our compiler is working fine. Now let's move to our program once again. Here, if you see in this program, the first thing is that we need a window, right? A window on which we can draw stuff. So how we create a window in Sfml? It's very simple. How can we do that? First, we need to initialize the object for window. Now, I'm saying object, it means it must be referring to some class. So the class for creating the window object is sf render window, and the object name is window. So you see there are few errors. Why is that so? Because we never told our compiler, or we never included the files or the header files of the library which are required in order to create a window. So the header file name is hash include sfml slash graphics.hpp. So this is the header file which would be required in order to create window and to draw shapes over the screen. Now let's just wait. Look, you see the error is gone. So if you find it a bit confusing, you can also follow along, and also you can refer to the SFML documentation for how to create screen and how to draw stuff. So let's say I'm drawing 2D stuff. So let me just open this link, and if you see that here is what a typical main loop looks like. To draw the entities provided by the graphic module, you must use a specialized window class sfWindow. This class is derived from sfWindow and inherits all functions. So you don't need to go into much details. We will discuss that later when it will be required. Everything that you have learnt about sfWindow creation, even handling, controlling. This window class, which is sfWindow, has lots of member function. So this is referring to them. Now we can use those functions in SF window and SF render window class as well. So it's like if you will learn a single class, let's say if you learn the render window, you will automatically will be able to work with SF window as well. Now on the top of that, SF window adds a high level function to help you draw things easily. So as we are beginner and I'm new to programming, so we need to do easy things. So this is how we create a window. Create the window with SF render window object named window, and it's in constructor, like creating a window by passing the values in constructor. We can do this in this way, or we have a specialized function for this. So I'm going to use that function so that it will make more clear how we are going to create a window. The function is window, that's our object of type render window. Dot, to call a member function, we need to use a dot operator. Now you can see we have bunch of member functions over here, but from them we just need a single function for now, which is create. Now if you see that this create function have two definitions, right? So we are more interested in the second one for now, which asks which accept few values, which is SF video mode. We'll discuss it later. Constant, a title, and a type or a window style, and a context settings. So let's make it a little bit easier. For now, we are just using two things. First is video mode, SF video mode, and you see we have multiple definitions for it. So what does it say? Video mode defines a video mode with height and BPP. What does it mean? So video mode is an object or is a class which defines the height and the width of our window, and it accepts two unsigned integer values. First one is for width and the second one is for height. Let's say our window should be of height 6 should be of width 680 pixel, and let's say height should be 600 pixel, and also we can pass a constant string for title. For now, let's say the string title is shapes. Cool. We have initialized a window object by calling the create function, and we initialize and we define values to the data members. And one more thing I need to add over here is SF window. You can see over here is a kind of class, right? Because it has constructor, but we are not creating any object for it. So what we are doing here, we are making a temporary object for SF video mode. You don't need to worry about the temporary object for now. We will discuss it when it will be required. However, you can read it over the internet. That will be this is very easy. However, do not worry, as I told. As we gradually move, we will discuss most of the concepts. Now the window is created. We need a way in which we can display this window over the screen. How can we do that? Simple. We can use the object which we have just created and use a function called display. Now, if you see the display function, display on screen what has been rendered to the window so far. This function is typically called, after all, OpenGL. We don't need to go into much details. Now, one thing that you need to know, look over here, SF window display. So it is a function or a member function of class window, but we are able to use it in SF render window because this SF render window class is inheriting all the properties of the window class. Yeah, I know it might look a little confusing. So what? Let's see here. It is our window class, and it has a child class named render window. So as it is a child class, it should have its own member function, as well as this class can inherit the member function of this class as well. Right, so window is created. However, if we run this, we will see that window will not stay long on the screen. Why is that so? We will discuss it. So for now, let me try to run it and see what will be the error, or will it run without any error. I'm using the same command to run this, which is g++ main.cpp. Enter. You see, there are bunch of errors. Let me just make it a little bigger. So what these errors are telling is undefined reference to SF string constant, undefined reference to SF video mode, undefined reference to video or window. Why is that so? We have already included the header files. So we have included the header file, but we need to provide the library as well, or a reference to the library, so that this thing can be linked. How can we do that? So if you go to the tutorial, and as I already told you, I'm using Linux, and if I go over here and if I see there's a link Sfml in Linux, so it will tell us how to draw or how to run and program. So I'm just copying and pasting this command. I will tell you what this command is doing. Paste. Now my file name is main.cpp. So let's see. G++ means we are running a C++ source file. We are running a file name cpp main.cpp, and we are creating its object with a file name sfml/app, and we are including this libraries, which is lsfml graphics, lsfml window, lsfml system. Now Let me just hit enter and see what will be the output now. You see it compiled without any error. See over here, an object, or let's say an output file is created. Let me just run it. You see, window appeared, but it disappeared instantly. Why is that so? Because we didn't define any way in which window can stay as long as we want. How can we do that? So if we follow along the tutorial by Sfml, you see there's one thing, which is run the program as long as window is open, right? But we didn't define this in our program yet. So what we can do, we can use a while loop, and the while loop run only till the condition is true. So what will be our condition? So if you see, the condition should be run the program as long as the window is open, right? So the condition should be run the program as long as window is open. So we should have, or we should find a way in which we can tell our loop that window is still open or not. How can we do that? We can use our window object that we have just created and call its member function, which is open. What this function do? This function will return a boolean value in terms of true and false. If you see, tell whether or not the window is open. So if the window is open, we want to display this window. As long as window is open, display it. Keep it open. In short, we are saying our program to keep it open as long as it's open. Now we will see that we will be able to run the program and the window will also appear over the screen for a longer time, but it may possible the program will crash. We will see it, why it will crash. So here you see the window is here, right? But I am unable to close it, and it, as I said, it will crash. So it crashed. Let me run it once again. Window is here, but I am unable to close it. It got stuck. So we should also define, or we should also provide some events to handle the state of window. Because if you see over here, we are just telling our loop if the window is open, as soon as we run our program, we see the window is open. So this loop is continuously looping, or this loop is continuously running without checking any event, whether the window is closed or we hit or we clicked on the cross button or we did something else to in our window. So we need a way in which we can handle the events. How can we do that? So if you see over here, check all the Windows events that are triggered since the last iteration of the loop. So what does it mean? What will it do? It will tell our operating system to collect all the events for this specific window and work on them or process them, right? So we should need a variable or something in which we can store these events. So for that we have a special kind of variable of type event. So what is event here? Event is a class and event this is an object. So you see, check all the Windows events that were triggered since the last iteration of the loop. Cool. As you see, we need to check every time. So we are using the while loop once again, and we are calling a member function of object window, which is poll event, and it will accept a type event. So what will it do? Let's say here are our event list, event queue. So what does event queue means? FIFO, first come, first out. So here it is. Let's say if we press the cross button, it will check and see, yes, there is an event. It will process that event and work according to it. Let's say if I press the W key, see, yo, there is an event. Then it will process this event and work accordingly. If we say there is an event A, like user pressed the key A, then it say, yo, there is an event, process it. If it see there is no event, then it will not process it. As simple as that. So now we know the way in which we are taking the event. Now we should define what kind of event it is. So I'm saying if event dot type is if the event dot type is same as SF event closed, go ahead and close the window. Now let me run it once again and you will see there is a difference. Now if I am running this program, you see that it will not crash. So it is not crashing, and now I am able to close it as well. Let's close. Let's close. Successfully closed. Right? Okay, let's see what's next. So now we have already cleared the window and we have created it. We have defined our events. Now let's see what next we have to do. So if you see, we have successfully obtained this much. We have created a window, we define the title, and we are able to close it. These are the three things that we have already achieved. Now the next thing that we need is a way in which we can draw a shape over on the screen or over the screen. How can we do that? So to create a shape, we have a special class which is shape, but we will not gonna use it. We will gonna use circle shape because in this tutorial or in this program we are most going to work with circles only, right? So I'm using a class circle shape and creating an object named circle. As you know, think it as like you're drawing something on a drawing page. Don't think it as a screen or a window. Just think it as of a drawing page. So let's say this is a drawing page that you have and you want to draw something. So what properties you can define? Let's say if you want to draw a circle, what properties you can define for this circle? It can have some color, it can have some radius, it can have some position, like where do you want to draw it? You want to draw it here, you want to draw it here, you want to draw it here, or you want to draw it here. It can have some position. So these are the most basic properties that you can define. A shape, a shape can have color, a shape can have position, a shape can have size, a shape can have what we say thickness, and it's true for every shape. If you want to draw a triangle, you also need some kinds of properties like color and the size of the triangle. Same goes for rectangle, same goes for pentagon, same goes for every shapes that you can draw over the screen or on your drawing page. So this is what we are going to do now. So we have successfully defined our object named circle. Now, as it is a class object, it should have some member functions. So we can access those member function using a dot operator. So these are all the member function that this class have or this object can call. So for now, we are using a member function set radius. As I told, we can set a radius. And you see, it accept a float type. radius. So let's say I want to pass 50.0f. We are using f to tell our compiler this is a float value, not the double value. Now we have already created an object. We need a way in which we can draw it. So we are using a draw function of our window object and passing what we want to draw. We want to draw a circle that we have just created, and also, yeah, so now the circle is created, and now let's see if it is displaying over the screen or not. So we got a small white circle like a moon. Now the circle is created. If you see our program, we completed 4 tasks. First, we defined a window, we defined the title, and we know how to handle close event, and also we draw a circle over the screen. Now, as I already informed that we can have multiple properties for circle. So we can set circle dot, let's say I want to set color. So color will be say red for now. I want to set the circle position as well. So if you see, the circle position has two definitions. One is constant SF vector 2f position, set the position of the object, or we can pass float x and y. So for now I'm passing float x and y. We will discuss what the vector is in later videos. So let's say I want my circle to be at 0.2f, 200.0f, and 200.0f location position. So now let's see if there are any changes to this program. You see the circle is here instead of here, and now it is of red color. So we know how to set positions, and we know how to set color, and we know how to set radius. One more thing that I need to show is circle dot set point count function. Let's say I'm passing 3. Let me run it once again and I will show you what set point count is. Here it is. It's a triangle. So what does it mean when I'm calling? So first of all, you should know how image is drawn or how shapes drawn over the screen. It's not drawn like I'm drawing like this, or it's not like you draw a shape in your drawing page. So how does this work? So what it will do, it will create dots like this on the screen and will join all of the dots. The more dots will be, the shape will be more circular. Similarly, if I am passing 3 dots only, then we will be able to draw a shape with 3 point count. That is 1, 2, 3. If there will be 100 point count, then it will be a circle. If there will be, let's say, 50 point count, then I can say it will be something circular but not too much. You can able to see some straight lines in this. This is what point count is. Now our program is almost done. Now we just need a way in which we can make this thing randomly. Like as you can see, there are multiple of shapes are creating, right? So I already shown how we can create an object for a circle shape and what point count can do. So if you see, every second almost 60 or 70 shapes are creating. So does it mean we need to define 60 or 40 objects for the same? No. What we can use a special library of C++ called random. Okay, and in random, I'm creating a random engine by using its syntax, which is default random engine, and naming it as random engine. Cool. So now our random engine is created. Now we need a way in which we can define the radius randomly and within a certain range. Like we need a range. So how can we do that? How can we do that? So for that, I'm using something called uniform real distribution float. So it's not like that you need to learn this. This is just a syntax of using random library. Now I'm naming it as rand radius and I'm defining it should be in range between, let's say we also want triangle, so it should be in range. Now we want it should be in range of, what does it mean? The smallest shape that we can get on the screen is of radius 10f. The largest shape we can get on the screen is of radius 10f, is of 50f. Now we define a random radius. So what I can do, instead of using radius, I can simply pass the rand radius that I have just created and use this random engine to create random values in between 10f and 50f. So if I run this, you will see some changes. Now see, it's small, very small. And if I run this again, most probably we will see the shape of same size. See why it is? Because we need to tell the frequency of generating the random number. For that we need to define something called seed, random engine, that we have just created, and calling its function called seed and passing a value, let's say time 0. So as you're using the time, we need to include the time library as well. Hash include time.h. Now let me try to run it once again to see if there is any difference. See, now the triangle is larger than before. Similarly, we want to make it at different position every time. So what we can use the same thing to define the position. So let's say rand position x. What should be the value of x? It should be in between 0 to 680 f, and the y should be 600.0f. So however, what does this x and y mean? So if you know, there is a thing called Sarstrian plane, maybe, right? In which we have four x's, x and y. X positive, x negative, y negative, positive, and the y negative. Similarly, in our window, we have these x's. but which are defined in a different way. This side is x positive, however, this side is y positive instead of negative. It's an inverted y-axis. So when I'm saying x and y, it means that I'm defining the position in the terms of xy. Let's say I said x is 10 and the y is 20, which means our shape will be drawn 10 to the x-axis and 1 to 20 to the y-axis, which is here. So our shape will start drawn from here to here. Like it depends on the other properties like radius. This is what x and y means over here. So there is also one more thing which we will discuss later, which is, and that thing is called vector 2f float x comma float y. So this is what we need to discuss later. Vector 2f. So let's come to the point once again. Now we have defined a way in we can set the random position. So what I can do, instead of passing this, I can use our random positions, which is randx, passing the random engine so that it can create random values in between the range that I have just defined. Similarly for the y-axis, passing the random engine, it's done. Now the only thing is left. The only few things are left. First, we need multiple shapes. So it can have point count 7, 10, maybe 12, maybe 13, maybe 2, maybe 3. However, the lowest point count that we will be having in this program is 3, because there is no point of defining it 1. If it will be 1, it will be a simple dot over the screen, or maybe it will not display anything. If it will be a 2, then it will a single line, right? So we will be defining it in between 3 and 100. So we also need to randomize it. So for that I'm using uniform in distribution and naming it as rand point count, and it should be in between 3 and 100. Now I'm passing this over here. Okay, so it's done, right? But there is one problem in this program. Like if I run it for now, you will see a circle is created and random position with random radius. Now let's try to run it once again. You will see again the circle is created at random position. It's not circle, but it's looking like a circle because we have defined a point count in between 3 and 100. So it can be anything in between that. However, the thing that we have noticed is we got a circle at a random position with random size with random point count. So the only thing is left is we need to define the random colors as well. So how can we do that? So we all know that the random colors can be defined with the value R, G, B. The mixture of these three values can give us a random color, and every and all values in between the range of 0 to 255. So we can use this concept over here. So what I'm doing, as these are the integer values, so I'm defining this or declaring these in uniform in distribution. So the first value will be say rand R for red color, and in between 0 to 255. Second is rand green 0 to 255. And the last one is rand blue 0 to 255. So instead of passing a static color, what I can do, I can use the SF and the color class, and in this color class you see we have multiple definitions, and the one is to give the color. Let me do it once again. SF color. So you see we have multiple definitions. So we are going to use this one, which is SF unit red, green, blue, and alpha channel. We will discuss what alpha channel is in later videos. For now, let me pass the random values for red, and I'm passing a random engine so that it can create values in between the defined range. Rand green, and let me pass the random engine once again. Similarly, rand blue. Let me pass the random engine in this as well. So it's almost done. We got a way in which we can define multiple colors. Now let's run it and see what is the difference now. See, we got a circle with color yellow. Let's run it once again. See, we got a circle with different color at different position. Now, there's one problem in this program, which is we have to manually run it every time in order to get the shapes at different position. What we can do, we have defined all the properties outside of a main loop. Instead of defining these properties over here, we can define them in this section, which is called update. Okay, let me just now if I will run this, you will see small difference. Now it's done, but it's creating image shapes so fast that we can barely see them. How can we limit this? So for now, what I have learned, how can we limit this is by using a method of by using a method for window object, which is set frame limit. I'm setting it to 30, which means this loop will run 30 times, or this loop will show 30 frames per second. So if I will run this, I believe the program should be a little slower than before. So now you can see it is almost done. So if you can see over here, there is one more thing which is defined over here, which is window.clear. So let me just tell you what will it do very quickly. So if I will call this window.clear function, so what will it do? It will clear the window every time before creating any new frame over it. So it will look like this. However, we want it to stay on the screen. We want shape to stay on the screen as long as we want. So that's why we are not using window.clear for now. Here you go. So let me summarize what we have learned in this program, in this small program. So in this small program, we learned how the structure of the program how to create a window, how to create shape, how to use the library, random library, and X and Y axis, how to display things over the screen. That is it. Difference between main loop and the event handling loop. This is what we have learned in this small program. So I believe you must have enjoyed it. If you have any suggestions, kindly give your suggestions in the comment section or in the comment box. And yeah, that's all. If you like it, you can subscribe it. If you don't like it, kindly subscribe it anyway. Thank you guys. Have a nice day ahead. Bye now.